So I'm Val Fajardo. I'm a Canada Research Chair here at Brock University, and I'm the head of the Muscle Plasticity and Health and Disease Lab. Yeah, so I was born in the Philippines and brought to Canada when I was 3 by my parents. And the idea there was that they wanted to bring myself and my siblings over to Canada to create better opportunities for us. And I'd like to think that now, as a Canada Research Chair, that I took full advantage of that opportunity. In terms of what led me to science, I always loved solving puzzles, especially math. I really enjoyed math. The problem there was that my twin brother also really enjoyed math, and I'll admit he was way better than me and always solved the problems faster than me. And so science was kind of my path towards independence. Yeah, so our lab focuses on improving muscle health to improve whole body health. Our muscles account for 40 to 50% of our body mass. And typically, when you think about muscle, you think about movement. You think about getting from point A to point B, but our muscles are much more important than that. They're important for metabolic regulation, for insulin sensitivity, for thermoregulation, or keeping our bodies warm. So we're trying to improve muscle health in a variety of conditions, including muscular dystrophy, aging, obesity, and of course, spaceflight. With spaceflight, we know that when you go up in space, if you don't use it, you lose it. And because of the microgravity that the astronauts experience, they tend to not use their muscles as much, especially the muscles that fight gravity, or that never-ending downward pull of gravity, the postural muscles. And so what we're trying to do is preserve muscle mass and strength while the astronauts are up there, to not only enable the mission, but also to improve the health of the astronauts up there. So our involvement with NASA came from an email and a little bit of luck. So I sent an email asking about the potential of us getting some samples, some muscle samples, to look at a PET enzyme that we study in my lab called glycogen synthase kinase 3. And I was pointed in the direction of NASA's Biospecimen Sharing Program, which is this really unique and fantastic program aimed at maximizing the amount of data that you can obtain from these samples. We know that these missions are very costly, and so NASA has this idea of, let's try to send the samples to qualified researchers to see if we can maximize the data. And luckily enough, we sent in a proposal and we were awarded some samples from previous missions. We published a few papers on these samples already, and this really led to us now working with them in December for their Rodent Research 20 mission. And from this mission, what we're trying to do is provide the NASA scientists some contractual data. And what we're trying to do is enable open science. And this is a mission really led by Ryan Scott at NASA Ames. And the idea is to create rigorous, reproducible, and freely open data. And so by contracting the muscles and collecting the data at NASA, our idea is to share that data with the scientists, such as Dr. Lauren Sanders from Gene Lab, so that we can collaborate, and they'd be looking at proteomics and artificial intelligence, trying to figure out novel protein targets that potentially related to the impairments in muscle weakness, in muscle strength.